Hello viewers, question 1. We have two 1,100 kilogram cars crashing into each other, travelling in opposite directions at 21 metres per second. We need to firstly find the total kinetic energy. So the kinetic energy is 1/2 mass times the velocity squared, and the mass we're given to be 1,100 kilograms times 21 is the speed, which we need to square, and we get 242,550 joules. But that is just the kinetic energy of one car, so we need to multiply that by 2, and if we do that we get 485.1 kilojoules. Okay, so that was part A of the question. Part B. So what speed do we expect after impact if the two cars stick together? So what would happen here is, bear in mind that we've got two cars travelling in the opposite directions, both with the same mass and the same speed. So the situation is symmetric. Neither side is going to be favoured over the other. So if they stick together, they are going to just stick and stop on the point at which the impact occurs. So the speed after collision will be 0. We know the kinetic energy is 1/2 mv squared. If V is 0, then EK would also have to be 0. So there's no kinetic energy after impact, which means all of that energy must have been converted into other forms. So what other forms would there be? There would be some heat generated in the collision. There would be some sound, you'd be able to hear the collision. A small amount of light, there would be a spark or two, but not all that much. Most of the energy will go into the destruction of the cars, so it would be deformation of the cars. Find the total momentum after impact. P equals mv. So for the first car it's going to be 1100 multiplied by 21 plus second car is going to be 1100, and as it's going in the opposite direction and we're considering velocity here, this is going to be negative 21. That negative deals with direction. So we end up with a total momentum of 0 kilograms metre per second. And since we're dealing with a collision, that total momentum must be conserved, so total momentum after impact must also be 0 kilograms metre per second. So question F, hence determine the speed of the wreck after collision. So V equals P over M. P is 0 because that's the total momentum after the collision, and on collision they stick together, so we treat them as a single object of mass 2200 kilograms. The two cars stuck together combining to form a single object. So that gives you the speed of that object after collision, which is 0, and that shows that what we expected in question B is actually true. That proves that the total speed of the whole wreck is going to be 0. And part G. So we've now got a car of mass 1,234 kilograms is stationary when a truck of mass 14,321 kilograms crashes into it at 15 metres per second. If the car and truck stick together on impact, find the speed of the wreck after impact. So before impact, let's look at what's happening before first. So before impact, the car is stationary, it's not moving, so therefore it has no momentum because V equals 0 for the car. Therefore, all of the momentum is in the truck. So P is going to be M times V, which is 14,321 times 15. And that's in kilograms meters per second. And after, the total momentum is going to be the same. So P is equal to mv there as well, which is also going to be equal to 14,321 times 15 kilograms meters per second. So the m and the v here are dealing with the mass and the velocity of the wreck, of the combined truck and the car stuck together. So when they stick together, they're going to create a single object with a mass of 1,234 plus 14,321, which is 15,555, is 14,321 times 15, so that's going to be multiplied by V, and therefore we need to find V, which is 14321 times 15 divided by 15555, and if we calculate that, we get 13.8 meters per second. And it's no surprise that the final speed of the wreck is much closer to the speed of the truck than it is to the car, since the truck has most of the mass and therefore is going to dominate the collision. Okay, thanks for watching. Over and out.